Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this specific video, we will start our new algorithm with respect to the machine learning. Now in this algorithm, we will talk about random forest per se. I hope you all understood the concept of decision trees and whatever learning I have shared with you with respect to the decision tree part, mathematical intuition, everything is pretty much clear to everyone. Why I'm saying so? Because in today's session, when we're talking about random forest, which is a ensemble technique, we will talk about what is the meaning of ensemble technique. You will observe that internally decision tree algorithm is something which is working on. So how it is working, what is the inference of that, whatever limitation we have talked in decision tree with respect to the overfitting problem, how this algorithm will be able to avoid that particular overfitting issue. Everything we will cover up. So without wasting any time, let's get started and we'll try to deep dive into the, first of all, mathematical intuition behind random forest. So whenever we are talking about this random forest algorithm, first thing you have to understand is you will heard this term even in the standard books, even in the documentation, that it's a bagging algorithm, right? The full form of bagging is bootstrapped aggregation. Let's try to understand that what is the meaning of that, or what is the inference of by saying this term, step by step. Okay, so this algorithm is a part of a ensemble technique in machine learning. Ensemble technique in machine learning. So let's try to get an understanding that what is the meaning of ensemble technique. See, when you are applying any model, let's say a single model, let's say M1, which belongs to a decision tree, right? So what is happening is that you will be able, whether you are trying to apply a classification task by calling a decision tree classifier, I hope that you can now correlate with the things which I'm saying, because in the previous session itself, we have finished our decision tree algorithm. And we know that when we're talking about decision tree, it is widely used for both the tasks, whether it's a regression task or a classification task. And let's assume that you have applied a model of decision tree to solve any one of the tasks. Now, what is happening is we have seen that sometimes what happened might be that this model suffers from a problem of overfitting, where there is a very high chance. And yes, we have understood that we have a techniques of pruning, maybe post-pruning and pre-pruning, by which we can avoid that. But now we are talking about ensemble. Ensemble means that we have multiple algorithms working together. For example, what will happen is we will be having maybe, as of now, I am assuming 5 models available with us, which is M1, M2, M3, M4, M5. Every model is a part of a decision tree only. DT1, DT2, DT3, right? DT4 and DT5. So every model is a part of a decision tree, means you are trying to implement a decision tree on top of the given models that we have, right? Now, what you will be able to observe here, that what is happening is in every specific model, it will try to take randomly data, right? And will try to form a model. Curation training will happen, and that subset of data which is taken randomly by the model, right? Subset of data which is taken randomly by the models, that subset will be done by replacement. Means it's not that there are very high chances that similar data points can also come into picture, right? So what you will be able to observe that what is happening in the random forest is, specifically in random forest case, those multiple models which I'm talking about belongs to decision tree only. So we have a separate models, contains a separate subset of data points taken randomly by the model. And now what will happen, every model is responsible to give the predictions. Now, for example, if let's say it's a classification task, let's assume that, we are talking about a diabetes prediction data, and the model is giving us a classification that whether a person is diabetic or not, or, whether the class belongs to 0 or 1. So what will happen is it will try to take the prediction of every model. For example, decision tree 1, model M1 says 0 prediction, M2 says 0, M3 says 0, but M4 says, let's say 1. And then let's say M5 also says 0. So what will happen is that there is a concept of something called as majority voting, which will come into picture. So here there is a concept of something called as majority. You will be able to observe voting, and as per the majority votes, whatever be the final prediction will happen is 0, because you can clearly observe that 0 classification part is given by 4 models, and only single model DT4 says that the prediction will be 1. So via this majority voting, it will try to see that what is the specific majority class we have, and that is where we will be able to get or our model will be able to give us the final output, final prediction. Now, if it's a regression based scenario, let's assume that we are trying to create a model which is basically doing a regression task, maybe predicting a house price. And let's assume my first model says that the price of the house is maybe 2 CR. Second model says it's 1 CR. Third model says it's 3 CR. Fourth model says it's maybe 2.5 CR. And let's say the last model is saying M5 that it is, let's say, 4 CR. So in case of a regression based scenario, you all know that prediction will be of continuous number. So what will happen at the end of the day in the regression task, that it will take the average. My model will take this random forest algorithm will take the average of all the given predictions. All the given predictions, which all my 5 models are giving to me. So what will happen is it will be the value of 2 CR plus 1 CR plus 3 CR plus you can say 2.5 CR plus 4 CR divided by the value as 5, because we will be having 5 separate continuous values, the models that we have. In random forest, we have something called as a parameter called as n_estimators, right? Which basically indicates that how many number of decision trees you want to curate. So let me just open this. You will be able to see it's one of the most important parameter. You will observe that maximum parameters are similar that we have in a decision tree, but this is something which is quite interesting. By default, the value of n_estimator is 100. Means by default, if you are calling a normal random forest classifier, it is calling internally 100 separate decision trees working together to curate the output, and depending upon the final predictions, if it's a classification task, majority voting will be done. If it's a regression task, the average will be done. So you can see that random forest is an estimator which fits a number of decision tree classifiers on various subsamples of the data set. So it will try to take a samples of that and will try to fit that model. Use average to improve the predictive accuracy and control the overfitting. You all know, right? It's a practical use case where, for example, if let's say you are confused about some decision part, right? You don't know in your life that which particular decision is correct. So what you will do? You will try to ask from 10-15 people, and you will see that okay, if maximum people are giving me the similar guidance, so I should follow that path only. That will bring a confidence within you, right? That might be this decision is correct. Same thing is going for the models part also. Instead of relying on a single model of a decision tree where it is giving us a prediction of 0 or 1, why not to apply multiple decision trees within one algorithm, so that we will be able to get multiple predictions, and whichever model is giving us similar predictions, that will be the final answer. Or in a regression task, why not to take an average of that? So what will happen is that problem of overfitting, which we have discussed in a decision tree, will be automatically resolved, right? Here you can see trees in the forest use the best split strategy equivalent to passing splitter as a best to underlying decision tree regressor. Here I'll talk about these parameters, which I think I already have talked about, although in the decision tree itself, the criteria is by default Guinea, maximum depth is in default is none, minimum sample split, minimum sample slip. You will see that whatever the parameters we have for a decision tree, it's exactly the same. Even the inference is also same. The only difference is if you will be able to observe, in a decision tree, we don't have an underscore estimators, because by default, it is single algorithm only which is working. But in random forest, you will observe that multiple algorithms are working here. And all of these algorithms are decision trees only. Now you can ask me that, Priya, if it is like that, can't we, make M1 as, let's say, we will apply some other algorithm of logistic regression. In M2, let's say we will apply decision tree. In M3, let's say we will apply KNN algorithm. Maybe because in a machine learning, we have multiple algorithms for classification task. So why to apply a same algorithm of decision tree itself? It is possible, and that is where you will see in the documentation also, we have a concept of stacking. This stacking will help us to understand that, okay, we can stack different classifiers on top of this model. But when we're talking about this random forest, we will talk about that stacking and this voting classifier also in a separate video itself. But as this video focus is on a random forest, what I'm saying is, in this specific algorithm, decision tree is applicable. But if you have that question in your head that, Priya, can we apply some different algorithms? Yes, we can apply. We have a separate algorithms for that. But for now, to understand the concept of decision tree, it's very important to understand that in this specific case, decision tree is working on. Now, depending upon how many number of estimators you are passing, by default, as I told you, is 100. For example, in this case, when I'm making this video, in this explanation, I have taken this estimator value as 5. Just to demonstrate you that how the things are working on. Keep on working. Now, what is the advantage of using this random forest? Again, let's try to study that part also. One interesting thing you will see here, we have a training set. We are applying a random sampling with replacement. That's what I have told you. That's what the meaning of bootstrap is all about, right? Bootstrap. And when you're saying aggregation, why it is aggregation? Because we're trying to aggregate all the results. So we will be having different trained models altogether. By the way, I have taken this from a standard book, right? If you want, you can just refer this image from that itself. Here you can see that we have trained the model. We have, let's say, 4 models separately available with us. And now we have the predictions or the classifiers available with us. So we will aggregate these results. If you're talking about random forest, these algorithm belongs to decision tree, right? Where the training is going on. If we're talking about specifically a random forest algorithm, but when you are saying a bagging algorithm, right? In that specific case, you can apply any other algorithm as well. So we have a function called as bagging classifier also. So if you're calling this function of bagging classifier, in that case, you can apply any other algorithm also. So you can apply any other algorithm also. But the important thing is that all the algorithms will be same. So whatever be the algorithm going on in M1, M2, M3, M4, when you are saying I'm using a bagging classifier, it should be similar only. In a stacking, it might be different. You can use maybe in M1, KNN, in M2, you can use decision tree, in M3, maybe you are using, maybe logistic regression, different algorithms. But when you're saying bagging algorithm, bagging classifier, it means that you're using same algorithm. Maybe in all the 4 you're using decision tree, then it will become random forest only. In all 4 of them you're using KNN. In all 4 of them maybe you're using logistic regression. Any one of them you're using, right? I hope it is clear to everyone. So bootstrapped aggregation, it's a random forest come into that picture itself. Why it is called as an ensemble technique? Because we have multiple algorithms working and we're trying to ensemble, we're trying to aggregate the results of the multiple algorithms that we have. Now, let's talk about the advantages of this specific algorithm, random forest specifically. So you will observe that one of the beauty about this random forest algorithm, which we are discussing today, is that we will be able to avoid the problem of overfitting, which was there in a decision tree. That's the number one thing. You must have seen that in a decision tree, it suffers from overfitting a lot. So to avoid that issue, random forest is a good measure. Even you will observe that in practical real-time projects, real-time industry projects, you will observe that maximum number of time people are relying on this algorithm because of this power that this algorithm has, right? The drawback is that definitely if your data size is very, very huge, in that particular scenario, it might take a lot of resources, GPU's requirement might be more, the training time required is more as comparable to a single decision tree, because you can imagine that there we are trying to create too many decision trees within one algorithm itself, right? But good thing is we can avoid the overfitting and we can increase the accuracy. The accuracy or the evaluation metric automatically gets increased. That is the good or the beauty about this random forest algorithm. When we're talking about this disadvantage part, as I told you, when I'm talking about disadvantage part, first thing is it requires more training time to execute. So to train the algorithm, the time requirement is very, very huge, because here we are not trying to create a single decision tree, but multiple decision trees, depending upon what is the number of estimators we are passing. And by default, you have seen it's 100, which is again very huge number. Second important thing which you will be able to understand is that interpretability. What is the meaning of that? If let's say I want to see a single decision tree. So if you remember in our last session, when I was showcasing you the implementation of a decision tree, it was very easy for me to create a decision tree with respect to the 20 samples we have and showcase you that how internally the things are going on. I hope you will be able to understand that part also pretty well. But if let's say I want to interpret or showcase you the random forest having the number of estimators as 100, can you imagine? Is it feasible? Is it feasible for anyone to interpret the results? No. It's like internally the calculations are going on. Internally the things are going on in an appropriate manner, because we or the developers have written the code in such a way that it will execute in an appropriate manner itself. But the problem is, as a client, for example, if you want to tell to the client that, okay, this is what my model is giving to me, the numbers, you cannot showcase the reason behind that because it's not interpretable. So what we want in our model, whenever we are trying to train our model, is that apart from getting a good numbers or good accuracy, specifically I'm talking about in healthcare domain, we're also looking for a interpretation also, explainability also. The model should be explainable. For example, if let's say my model is giving some result, maybe if let's say we are working in a banking domain, and let's say the classification task is going on where whether we should provide a loan to the customers or not. So either the output will be yes or no. And if it is yes, maybe the answer is 1. If it is no, maybe the answer is 0. Definitely you have to tell to the customer, right? Whosoever is applying a loan, if you are saying that, or the bank is saying that we will not able to give you a loan, what is the reason behind that? Why you are saying that the loan is not feasible to give? You have to provide a proper justification for that, or a bank should provide that, right? So that is not feasible in case of a random forest. So interpretability is bit, I would say, difficult as comparable to a normal random decision tree that we're working upon, right? This is the disadvantage. One more interesting thing or an advantage which you will be able to see in the decision tree, in the random forest and decision tree also, I would say the more advantage part is that for a given data set that you have, you will be able to see the feature importance. I'll talk about this now. Feature importance means, let's say you will be having multiple features available in your data set. When I'm saying features, I'm talking about the number of columns that is available, right? For example, let's assume now this part is also there in the decision tree algorithm also. I have not talked about because I thought to discuss here in this video itself. And even in this random forest also, it is feasible, right? Although they're same only, right? It's just that multiple decision trees are working. Now I think you are clearly aware about this fact. So when I'm saying that these algorithms, these tree-based algorithms will be helping us to provide a feature importance value, what is the meaning of that? What is the inference of that? Simple inference is that, let's say if you will be having multiple features, F1, F2, F3, F4, F5, let's say, and at the last you will be having a target value. And let's say again, you're working in a banking domain where the target is that whether loan we will provide to the customer or not. So either the result will be 0 or it will be 1. 0, 0 or it will be 1. Now, what I want to see here is that out of the given 5 features that we have, what are those particular features which are highly important, which basically provides or which basically brings more meaning to the target column that we have, whether it is 0 or 1 out of the feature from F1 to F5, right? So this is the biggest question. And what this algorithms usually does, we have some parameter called as feature underscore importance underscore. So whatever be the algorithm that we are talking about, whether it's whatever be the classifier we are talking about, whether it belongs to decision tree random forest, we can get the feature importance of all the features that we have, the 5 features that we have. Now, whatsoever feature is having a very huge number of feature importance, it means that that feature is highly important, means that feature is highly responsible for the prediction of 0 or 1. So if, let's say, bank has to provide the reasoning behind that, so they can say that, okay, this is the 2 features which are quite important, and they are majorly responsible to get the prediction as either 0 or 1, right? Maybe the CIBIL score is one of them. So what I'm trying to convey is that these algorithms will basically help us to give us an idea of feature selection technique also. So what is the meaning of feature selection? For example, if, let's say, in our data, we will be having multiple features. And if we have multiple features, multiple dimensions are there, it's not very much good, because sometimes what happened is it leads to confusion, complexity of the algorithm, and algorithm will get confused and it will not able to give a better result. So something like correlation coefficient heat map that we have discussed in a EDA process of machine learning part in the initial projects, same thing you can apply just to check these algorithms. You can apply just to check that whether what are the important features we have. We can select those features and we can showcase that this is the importance of the features which we will be able to get there, right? So how basically it will be able to get that? That is the next important thing which you have to understand. For that, I have tried to take a very simple example just to showcase you that how this feature importance will be done. For example, if, let's say, if I'll go back to the main file, what I have done here is I have tried to call this function called as make underscore classification. Now, what this function usually does, this specific class of make underscore classification tries to, you will observe, provide a random n class classification problem. So if you will just mention how many number of samples of data you want. So as of now, I'm dealing with just 5 samples. The only reason is so that I will be able to explain to you the point also. And in terms of calculation also, in terms of mathematical part also, it will be very easy for me to communicate, right? Number of classes, let's say 2 classes are there. We are trying to classify our task into 2 specific classes. So what we have done is, when we are calling this function, we have tried to apply a decision tree classifier on top of this. And you can see that I have tried to create a plot of this. If you remember, the code part I already have discussed in the previous sessions. How can we create a decision tree on top of this? So what I have done is I have tried to copy this picture on my notepad, and this is the same pic which you can see here. So I have taken from that collab file itself. Okay. Now I just want to explain you. I hope that these values are pretty much clear. What is this Guinea, number of samples, and values? So if we will be having 2 classes, 2 values will be there. One class number of samples will be 3. Another class number of samples will be 2. You can see very clearly. Now you will be having 2 features only, right? You will be having only 2 features, 0 feature and 1 feature. So what you will do is you will try to first of all get the feature importance value of 0th feature also. This is the 0th feature value. 0th feature importance you will try to calculate, and also you will try to calculate the first feature importance as well. We have 2 features, 0th and first. So what is the idea? We will try to evaluate the value of both of them. How basically we can evaluate? You can see this formula in the documentation also. I'll showcase you just now. Just try to understand. It's very easy. Maybe it looks very difficult, but it's very, very easy, believe me. For example, I just want to evaluate the feature importance for the first class, which is this one, x1, right? For this x1, I want to evaluate. It indicates n underscore t. Simple meaning is how many number of currently samples you have divided by capital N, which is the total number of samples you have. So here you can see we have 5 divided by 5. In bracket, what is the impurity? Guinea is the impurity, which is 0.48. 0.48 minus. Now this is something where you have to focus on the right subtree of your tree, and this is something where you have to focus on the left subtree of your tree. Okay. So here you will be able to observe that when we're talking about right subtree, same thing you have to communicate. Number of samples 4, out of how many samples? 5, because your parent node or parent data is having 5 number of samples. So you will be able to say it will be 4 by 5 into the Gini value, which is 0.375, minus, go to the left side, number of samples 1 out of 5 into Gini value is 0. We have tried to evaluate the feature importance for this first feature that we have. So this is the feature importance which we will be able to get. 0.18. You can do the calculation because I was doing the recording, so I have done it prior itself. If you want, you can do it at your end. Maybe if something is wrong, please do let me know as well. Same thing. So we have done for the first feature importance part, but I also have to calculate for the 0th importance. So again, we have a split on the left part of 0 and right part of 0. So we will apply the similar formula here as well. So you can see we have 4 samples out of how many samples? 5. 4 by 5. In the bracket, if you will be able to see, the formula says impurity value of the current node, which is 0.375, minus. Now go to the right side. How many number of samples we have? 1. Out of total, how many? 4. Into Gini, 0. Minus 3 by 4 into 0. Now this whole term will become 0. This whole term will become 0. Majorly what we have to deal is 4 by 5 into 0.375. And I think this number will come out to be 0.30. Now you will be able to observe we have the individual values or the feature importance values for first feature also and the second feature also, 0th feature also, first feature also. Now, if you will see the definition of this in the given documentation, you will be able to understand that. Feature importance, can you see? It's a documentation of decision tree classifier. It's normalized total reduction of criteria by feature as a Gini importance. Or here also, if I'll just showcase you the same thing, if I'll just search feature importance, you will be able to get that feature. Can you see? The impurity based feature importances. So it is available in both of them, in the random classifier, random forest classifier also, and in decision tree classifier also. If you want to see the net, you can say feature importance, so you have to normalize it. I think you have seen in the definition itself. What is the meaning of normalization? The feature importance for 0th feature is, what is the value of this feature? 0.30 divided by total feature values or importance values of all the features. So it was 0.30 plus 0.18. Similarly, feature importance for the first feature will be 0.18 divided by 0.18 plus 0.30. So if you will just try to evaluate this number, maybe I'll do the calculation just now. I have not done this calculation. So let's do that. So if you can see here, 0.30 divided by 0.3 plus, I think we should have another calculator where I can use the bracket also. Maybe let's go for scientific. Now I think it would be easy for me to calculate 0.3 divided by, I think now I can apply a bracket. Yes, 0.3 plus 0.18. So if I just close this, I will be able to get the number as 0.48. This is the feature importance for 0th feature. Let's try to evaluate for F1 also. Now you will observe that the addition of these two values. So why we are doing a normalization? This is the way to do the normalization. The only reason is the addition of this 0.48 plus another value will be equal to 1. So in other words, you can subtract the value from 1 also, but anyhow, because I'm doing it for the first time, I'm trying to showcase you, so I'll do it with you. You can say 0.18 divided by, again we have a bracket, 0.18 plus 0.30 that we have. It should be 0.30, I feel so, not 30, 0.30. So we are dividing 0.18 from here. How it comes to be 0.48? Let me just recheck it again. 0.30 divided by 0.30 plus 0.18. So it will be 0.48. Okay. This value is 0.625. Sorry, my bad. I have done the calculation mistake. And this value is, you can just verify again. So it will be 0.18 divided by, you can say 0.18 plus 0.30. And then you can just make it equal to, it will be 0.375. So if I'll just try to showcase you now the code work also, you can verify this number. If you will just click on this feature underscore importances and underscore, you will be able to get the same number which we got, 0.625 and 0.375. So I hope that now it is clear that how internally it is basically trying to give us the feature importance value, right? And even this formula also you will be able to see in this documentation itself. Can you see this formula from where I have picked up? So basically it is trying to give us min underscore impurity decrease. This is the weighted impurity decrease equation. And this is the same formula which I have used when I am trying to showcase you, right? N underscore T divided by N into impurity minus right side value minus left side value. So this is where I have taken this formula itself. So this is how basically these algorithms of random forest or decision tree is also providing us the feature importance value. So the important beauty which you will be able to see in this particular algorithm is that we will be easily able to see the feature selection part technique also in this case. If let's say somehow in future you're confused that we will be having so many features, which particular feature is having a highest feature selection part or feature importance part, you can directly apply this particular parameter of feature importances and you will be able to get that. I hope that this maths is pretty much clear to everyone. The important objective to take this example is to showcase you the maths behind that. Now, next part, what we will do is, we will try to do a implementation of random forest algorithm now, because till so far we have talked about the internal intuition behind that, but how this classifier works, what is its intuition internally, maybe let's discuss in the upcoming session, and then we will try to optimize this parameter also in one go. But I think so far whatever things we have covered up is pretty much clear to everyone. Basically, if I'll just have to recap, majorly we have talked about the maths behind random forest. We have talked about what is the meaning of bagging, what is the meaning of ensemble technique. We have talked about majorly what is this n underscore estimators parameters in random forest. We have talked about the advantage, number 1, avoiding overfitting, number 2, increasing of the accuracy, number 3, to get that feature importance value. Also, we have talked about the disadvantage of this algorithm at the same time. And I hope that these things are clear to everyone. Majorly disadvantage per se, we have our training time will be more, which I'll showcase you in the upcoming session when we will do the implementation of random forest algorithm. And in terms of interpretation also, it's a bit difficult to understand, right? So now I hope that you will be able to get a better understanding of how the random forest algorithm works, what is the internal intuition behind that, how basically we can implement that, what is the major difference between a normal decision tree versus a random forest, what is the meaning of bagging algorithm, what is the meaning of ensemble techniques, and how it is much powerful than a normal decision tree. With this, let's try to end this specific video, and I'll try to come up with another video where now we will see the new concept with respect to hyperparameter tuning. I think it is one of the most awaiting video. Till so far, I have told you that in terms of implementation, I'm using a default parameters. Now we will discuss that if I want to find the optimized parameters as per my data which I'm using, so how can we go for this hyperparameter tuning techniques? What are the algorithms that we have in that? So with the help of random forest, we will try to understand this stuff. But please make sure that these algorithms, this tuning techniques will be implemented in any of the algorithm. You can implement in decision trees, you can implement in further KNN, whatever algorithms you know so far, whatever algorithms we have covered up, in every algorithm you can use that. Okay, so with this, let's try to end today's video. Bye bye everyone, and I'll see you all very soon.